Welcome to the Deep Dive. We tackle complex source material engineering reports, white papers, you name it, and distill it down so you get the crucial info you need.
That's right.
Today we're looking at something industrial, often maybe overlooked, warehouse thermal insulation. But it's a huge financial lever.
It really is. It sounds pretty basic, maybe just a compliance thing, right? But the sources we dug into, they frame insulation as a core strategic asset.
Strategic? How so?
Well, it's not just about keeping things warm or cool. It's really about optimizing efficiency, protecting your assets, and ultimately boosting long-term profitability.
Okay, so that's our mission for this deep dive then. Let's unpack the science, the strategy behind it.
Exactly. We need to understand the different material options, what the key performance metrics actually mean.
Like R value, I imagine.
Precisely. Our value is key. And we want to give you the insights you need to choose a system that, well, doesn't just meet the code, but genuinely cuts your operating costs.
All right, let's jump in. The standard thinking is just, warm in winter, cool in summer, simple climate control. But you're saying, and the analysts we looked at agree, that's maybe only seeing, 20% of the picture? Why is good insulation considered one of the smartest investments a business can make?
Yeah, it's fascinating just how interconnected the benefits are. One source called the warehouse the heartbeat of modern business.
Okay.
And good insulation is basically what keeps that heartbeat steady and, importantly, cheap to run. We can break it down into maybe 4 core areas. First, the obvious one, energy and cost savings.
Right. Lower bills.
Lower bills, absolutely.
Yeah.
But it's not just marginal savings. Quality insulation drastically cuts energy use. But here's a key insight, something beyond just the monthly bill. It actually reduces the load on your HVAC systems.
Wait, how does that work? How does insulation save the actual heating and cooling units?
Well, it's about reducing how hard and how often they have to run. Peak demand, cycle frequency. When you've got good thermal resistance, the HVAC doesn't need to blast at full power nearly as often to hit and maintain the temperature you set.
Right.
It runs for shorter periods, it cycles less, it's not constantly fighting heat loss in the winter or heat gain in the summer, and that significantly cuts down wear and tear.
So it extends the life of the equipment.
Exactly. It extends the operational life, which means you delay those massive capital replacement costs down the line. It's a big deal.
Oh, okay. So it's not just saving on the monthly energy bill, it's actively protecting what could be a multi-million-dollar HVAC investment. That makes a lot of sense. What's benefit number 2?
Number 2 is product protection. This is critical. Think about anything temperature-sensitive electronics, chemicals, pharmaceuticals, even food.
Absolutely.
Insulation is just non-negotiable there. It protects goods from extreme temperatures, those sudden heat spikes in summer, or deep freezes in winter. One source mentioned a pharma warehouse, right? They switched from standard insulation to a high-density foam after losing just one shipment. It was a small heat spike during a power outage, but boom, lost product.
Wow. That really highlights the risk mitigation side of it.
Totally. And that risk part leads nicely into benefit 3, safety and productivity, the human element.
Ah, right. Often overlooked.
For sure. Better climate control means a safer, just more comfortable place for your employees to work.
How so?
Well, think about it. If workers are battling extreme heat up near the roof or freezing drafts by the loading docks, their focus drops. Productivity suffers.
And safety probably, too, if they're distracted.
Exactly. Stable, comfortable temperatures reduce physical stress, thermal stress. That helps with retention, fewer distractions, and fewer safety incidents. It all connects.
Okay, and the 4th benefit?
The 4th one is structural durability and health. This one's kind of the quiet hero.
How's that?
Good insulation acts like a defense against moisture and condensation.
Ah, condensation. Big problem in warehouses sometimes.
Huge. By stopping condensation from forming on the inside surfaces, especially on metal components, you prevent mold growth.
Which is a health issue, too.
Right. And you protect the structure itself from long-term corrosion and moisture damage. It keeps the building healthier for longer.
So when you add it all up, saving HVAC equipment, protecting valuable inventory, worker performance, even the building's structure insulation really does feel like a foundational very cost-effective improvement.
Absolutely. One of the smartest long-term plays.
Okay, so that discussion about protecting assets, it leads us right to the next question.
Yeah.
What are we actually working with? What materials are out there?
Good question.
Our sources mention quite a variety, but stressed that the best choice is always tailored to the specific warehouse, its design, its use.
That's key. But before we dive into the specific types of insulation, we absolutely have to define the main metric, R value.
R value, right. Heard it mentioned a lot. What is it exactly?
Think of R value as like the insulation's ability to resist heat trying to move through it. The R literally stands for resistance.
Okay.
So if heat's trying to escape in the winter or sneak in during the summer, the R value tells you how well that material stops it.
So higher is better?
Generally, yes. A higher R value per inch of thickness means better insulation performance, more stable temperatures inside, and better energy efficiency. It's your main comparison tool.
Got it. So looking at the options, what are the main players? Let's start with the traditional one, fiberglass.
Fiberglass, yeah, that's the tried and true standard. It's affordable, it's everywhere, and relatively easy to install. That's why you see it in so many industrial buildings.
How does it work?
It basically just traps tiny pockets of air within glass fibers. It comes in those rolls you see, or pre-cut pieces called bats, or even as loose fill that gets blown into spaces.
And the R value.
Standard fiberglass usually gives you about R3, maybe R4 per inch. It's kind of the benchmark for cost effectiveness.
Okay. Then there's the next step up, performance-wise. Spray foam insulation. Seems like the go-to for high performance these days.
Spray foam is where you get maximum R value and, crucially, excellent air sealing. It starts as a liquid, gets sprayed on, and then expands rapidly.
Fills everything up.
Everything. Every little crack, every gap. It creates this solid, continuous barrier. So it's fantastic at stopping air leakage, which is a huge energy drain.
And the R value difference.
It's significant. High-density, closed-cell spray foam can hit R6, even R7 per inch. You can see the performance jump compared to fiberglass.
Big difference.
Yeah.
Okay, besides those two main ones, what else did the research point out?
Well, cellulose insulation came up. It was highlighted mostly as an environmentally friendly option.
How so?
It's often made from recycled paper, treated to be fire-resistant. It's dense, works well when blown into wall cavities, but typically doesn't reach the R values you get with foam.
Interesting. Anything else?
For metal buildings, which are super common for warehouses, right?
Yeah.
Vinyl insulation is used a lot. Yeah, it's often a facing applied to fiberglass bats. The vinyl acts as a really important vapor barrier, stops moisture getting into the insulation. Plus, the facing adds durability, protects the fiberglass if it's exposed on a wall or ceiling.
Makes sense in a busy warehouse.
Ugh.
And lastly, reflective foil. That sounds different.
It is different. It's not traditional insulation in the same way. Fiberglass and foam resist heat transfer through conduction and convection.
Right.
Reflective foil tackles radiant heat. Think of the sun beating down on a metal roof that's infrared radiation. The foil reflects a lot of that heat away.
So particularly useful in hot, sunny places.
Exactly. Where the main battle isn't just keeping conditioned air in, but stopping that intense solar heat gain from getting in the first place.
Yeah.
It's more of a specialized tool.
Okay, this is helpful. Now, since most decisions seem to boil down to that choice between fiberglass, the workhorse, and spray foam, the performer, let's dig into that comparison. That feels like the critical choice for anyone listening who's planning a project.
It really is. This choice impacts your budget, the longevity of the solution, and the building's overall efficiency. Let's start with fiberglass advantages.
Okay.
It's simple, easy, quick, and affordable to install. No question. If you've got a massive warehouse, hundreds of thousands of square feet, fiberglass is often the most cost-effective material up front.
The go-to for big spaces on a budget.
Pretty much. It's the trusted choice for insulating things like soffits, internal partitions, and just the general shell of large standard metal warehouses.
So, sounds like the pick for maximizing scale with minimum initial spend. But if performance, getting that perfect seal, is the top priority, spray foam seems like it's in a different league.
It is, especially if you have specialized requirements. Spray foam's big advantages are that superior insulation value, the R value we talked about, and its air tightness.
Because it expands everywhere.
Right. By expanding and sealing everything up, you basically eliminate air leaks. And air leakage is a massive source of energy waste in many buildings.
So where would you definitely recommend foam?
Well, that higher R value and better efficiency make it the go-to for high-performance situations. Definitely cold storage. Or any warehouse storing perishables, pharmaceuticals, anything where even a small temperature swing could be a disaster for the business. The performance helps guarantee you meet those really strict temperature standards.
Okay, but let's talk cost. You said fiberglass is affordable. Spray foam, not so much up front, right? Maybe 3-4 times the material cost. Isn't that a deal breaker for businesses focused on this quarter's results?
That's the million-dollar question, isn't it? And why you need to do this kind of deep dive. Yes, spray foam has a higher upfront capital cost, significantly higher sometimes.
So how do you justify it?
You have to look at the total life cycle cost. Closed-cell spray foam, the dense stuff, it doesn't absorb moisture, it doesn't settle or degrade over time like some fiber insulations can. Its performance stays consistent for decades.
So the R value you pay for is the R value you get long term.
Exactly. And then you factor in the energy savings from that higher R value in the air sealing. Sometimes you can cut HVAC costs by 30% or even more compared to a poorly insulated building.
30%, wow.
Yeah. So depending on your local energy prices and the size of your building, the payback period for that initial investment in spray foam can actually be surprisingly short. It's an investment in guaranteed long-term efficiency.
Okay, understanding the materials is one thing, but the strategy is key. Where should managers focus their insulation efforts to get the biggest bang for their buck?
You absolutely have to focus on the areas with the most exposure, the biggest surfaces. That means the walls and, critically, the ceilings and the roof.
The roof is huge, literally.
It's massive. Heat naturally rises, right? So in winter, heat escapes through the roof. In summer, the sun beats down on it. In most warehouses, that huge roof area plus maybe thin metal walls are the main places where heat transfer happens. Insulating those well gives you the biggest, fastest return on lowering energy costs.
And you mentioned before, the solution needs to be tailored. An older building isn't the same as a new build.
Definitely not. With a new warehouse, you can design the insulation system right from the start, maybe integrate it perfectly with the metal building components.
Easier from scratch.
Much. For an older building, you might be looking at retrofitting, maybe injecting foam into existing wall cavities, or adding reflective barriers under the roof deck. Things you can do without a massive structural change.
So the goal is always the same: maximize comfort, maximize efficiency. But the how depends on the specific building.
Exactly. Its age, its construction, its specific use, even the climate zone it's in.
Okay, let's get really practical. If someone's sitting down with an engineer or a contractor, what are the key things they need to balance?
Okay, three main things. First, the cost. What's the immediate budget you have to work with?
Number one, always.
Always. Second, the R value requirement. What level of performance do you actually need? Local building codes might dictate a minimum, but your product storage might demand much higher. Dry storage is different from a freezer, right?
Completely different needs.
And third, the installation logistics. Can the warehouse operations handle the downtime or disruption that might come with, say, a spray foam application? Or do you need the speed of just rolling out fiberglass bats?
So cost, performance need, and installation practicalities.
That's the balancing act. The best insulation is the one that lines up with those specific goals. If top-tier efficiency for sensitive products is paramount, foam's high R value probably wins despite the cost.
Right.
If it's about getting a large general storage space insulated quickly and affordably, fiberglass is likely the answer.
And when it actually comes to doing the work, the sources were pretty clear. Don't cut corners here. First point for older buildings, just checking and maybe upgrading existing insulation can be a quick win.
Absolutely key maintenance point. Insulation doesn't always last forever. It can settle, get compressed, get wet, get damaged by pests.
Lose its effectiveness.
Exactly. Just replacing or topping up old, degraded insulation can bring back a lot of lost efficiency pretty quickly.
And the most important point, it sounds like, this is not a job for the in-house maintenance crew.
Oh, definitely not. Cannot stress this enough. Partner with experienced, professional insulation contractors.
Why is that so critical?
Industrial insulation, especially in big metal buildings, it requires specific know-how. Applying spray foam correctly, ensuring vapor barriers are perfectly sealed, dealing with corrugated surfaces, meeting all the fire and building codes. You need experts.
To ensure it actually performs as expected and lasts.
And is safe. You want quality, long-lasting results. Pros deliver that.
Which brings us back to the cost, the investment side. Worth saying again. The installation bill might look daunting initially.
It can, yeah.
But those long-term savings on energy, on HVAC maintenance, maybe even avoiding product loss, they really stack up. It makes insulation seem like a smart, almost defensive investment for the business.
It really is. Protects the bottom line, protects the physical assets. So yeah, we've seen insulation as way more than just temperature control.
Right.
Our analysis confirmed it. It helps with moisture, makes the building last longer, boosts safety, productivity, and it's just flat out the best way to improve energy efficiency in your whole warehouse operation.
Okay, so that leaves us with our final thought for you, the listener.
Ah.
Making the right choice here really hinges on getting clear about your vision, your primary goal. If you're planning an insulation project or an upgrade, you have to decide first. What's the number one operational driver? Is it achieving the absolute best efficiency, the highest R value, maybe to protect really sensitive, high-value products like in cold storage?
Where performance is non-negotiable.
Exactly. Or is the critical driver getting a large general-purpose space up and running quickly and as affordably as possible?
Speed and upfront cost are paramount there.
Right. Answering that fundamental question, maximum performance versus maximum cost effectiveness, that's what will tell you whether you should be looking primarily at fiberglass or making the bigger investment in spray foam. Which goal is truly driving your facility's needs?